Hey, I will talk briefly about some update with the GI system that recently was done. So basically, previously the how the GI system worked, we were using the SDF scene that you can see like here. So all the meshes objects are represented by the signet distance field volume. So it can be easily traversed with the kind of ray marching stuff for the scene. We also keep lighting them, and basically it works. So it's like having some light information on the surface of the meshes. And previously, we were doing the screen space ray casting. So for each pixel on the screen, we are basically casting the ray and checking the signet distance field hit, and then we evaluated the lighting. That of course was pretty slow, and it could end up being like a 5 to 8 milliseconds time on the GPU. So obviously that need to be optimized, and it had some like caveats, right? Like the regular ray tracing. So like the output was super noisy, so there had to be like a bunch of solutions to filter out and smooth out the final irradiance results. So this week I rewrote the uh, let's say lower quality options for it, but essentially many other system benefit from having this new GI system. So uh, let's find it. I'm calling it a light field, and what you can see now, this is the basically like a grid. Obviously, it's like a 3D grid. I can enable it like this on the debug options, but it's easier to show with the just camera plane only probes. So how it works is basically like you have those cascades. So it's like having a volume with the information about the incoming light for a given probe. Those points basically store the per axis information about the light irradiance. So I'm gathering lights, incoming light from the scene that is casted on that probe. So basically, you have this volume that follows the camera movement. So you can see that if I'm moving the scene, the probes are also changing because the how we have this volume following the camera, and this is like a helper. Uh, yep. So what you can see now is that if you have this cave, uh, you have those probes that are getting darker and darker. So essentially, this is basically like information for the surrounding objects, what ambient light looks like for the given probe. And in the end, the result is very similar to the per pixel ray tracing, because we have this pretty dense grid of the probes that kind of mitigate the potential low resolution artifacts due to the constant size of the grid. So in oppose, what would happen with the uniformly distributed probes across the whole scene, we would get like out of leaks and like undersampling of the light information. So like the probes would be spread too much apart to distinguish some more fine-grained light information. So what you can see here is that the further you go, this is the cascade 0, this is cascade 1, and so on, so on. So each time you bump up the cascade, it's being like a 2 times bigger than the previous cascade, both in size and also like a mm, distance between each probe separately. So let me show you some more like representative scene. So this is, for example, some case where I'm testing the GI solution. So here, this is the light probe distribution. So it looks pretty nice. And of course, when I show just the ambient, this is how it looks. And let me show you the old solution for the GI, which is the under the SS GI quality. This is actually it's a low quality, and this is the old way per pixel ray tracing. So what you can see is like the overall look is pretty similar. Obviously, you have the out of shimmering and like noise, because the how the ray tracing works, like it's super noisy and you need to filter it out clever way. So with the new solution, you're basically getting rid of the whole noise. So the filtering is like much faster and gives much better results, which is also cool. The other thing that is beneficial from the having this light field is that right now reflection probes can get the GI information. So without this option, like apply light field, the reflection probe would look like this. So that would be completely dark because the reflection probe doesn't know anything about the how the light propagates around the scene nearby the probe. But if we enable the light field, now it gets brighter because it gets the same bounces of the light as the regular scene. And this is the like the biggest benefit of the light field. So the GI information is stored and can be accessible from the off-screen parts of the rendering. So you don't have to need the screen space information to evaluate the GI. It's accessible for everywhere. The other thing that benefits right now with the light field is the particles. So right now you can see those three particle systems being spawning some smoke, and you can clearly see that it gets the bouncing of the light from those emissives. Oh, by the way, the whole cave is actually lit by those emissives only. There's just like those couple lights that doesn't influence the scene that much. So all this bluish and violet color comes from those emissive objects. The other thing that also like can get a little, not even a little, like a big boost from the light field is the volumetric fog. So this is the same scene with like a bit more dense volumetric fog lighting. I just changed the time of day to be like midnight, so it's like having a higher volumetric fog density. And if I go to the environment settings, change the volumetric fog GI scale, so it's 0, you can see how much of an impact the GI gives for the cool lighting effect for the volumetric fog, and like improves the overall experience and the mood of the scene. And here are more of the examples of the GI. So let's say here's the light actually just hits stuff around the volume of the sphere, but you can see that the rocks gets like a nice bounce from the light. Same like here, the light is hidden just inside this place, so it doesn't have like that much influence of the scene, but overall it gives pretty nice light bounces around. And it works in a feedback loop. So having the light field containing the GI information for the scene is basically feedback back to the this SDF lighting. So previously the multi-bounce for the SDF information for the scene was basically reusing and doing the ray tracing per like lighting cache texel again. That was pretty heavy for the competition. So right now it's just like a regular fetch to getting the light field information. And also the transparents can get like cool effects just like those particles. Another thing is that you can now have the reflection probes having the reflectance, so basically like a reflected IBL image that is driven by the light field. So essentially the only difference is that on the very high roughness the reflection is super similar to the regular GI ambient term, but you just need the different vector to sample from. So with this solution, you can have the this nice reflective surfaces respond pretty nicely to the GA. And I think that's all. Thanks, guys. See you.